Have you ever wondered what happens when a star dies? Picture this: a massive star, many times bigger than our Sun, suddenly explodes in a violent burst of light and energy so powerful, it outshines entire galaxies. This is a supernova, one of the most stunning and dramatic events in the universe. But how do stars go supernova? And why are these explosions so unbelievably bright that they can be seen from light years away? Today, let's dive into the fascinating world of supernovas and explore why they are some of the most awe-inspiring phenomena in space. It all begins with a star. Stars are like the engines of the universe, burning through fuel to produce the light and energy that powers the cosmos. But when a star reaches the end of its life, something incredible happens. In fact, it's one of the most powerful and brilliant occurrences in the universe. These stars, often hundreds or thousands of times more massive than our Sun, can explode in a supernova, releasing more energy in a single event than our Sun will emit in its entire lifetime. But how does a star get to this point? Well, stars live off nuclear fuel, and as they age, they burn through it, just like a car burns fuel to keep running. The bigger the star, the faster it burns its fuel. And as the fuel begins to run out, the star undergoes dramatic changes. For smaller stars, they slowly shed their outer layers and collapse into white dwarfs. But for stars much larger than the Sun, the end is far more explosive. These massive stars go out with a bang, a supernova. A supernova occurs when a massive star runs out of fuel to burn, and the outward pressure that was holding the star up against gravity disappears. Imagine a tug-of-war between the inward pull of gravity and the outward pressure from the nuclear reactions inside the star. As long as the star has fuel, the forces are balanced and the star stays stable. But when the fuel runs out, gravity wins. The star collapses inward at an unimaginable speed, causing a shockwave of energy that results in a supernova. The collapse is so sudden and intense that it creates a massive explosion. Now, what's so incredible about this explosion is its sheer brightness. Supernovas can be so bright that they outshine entire galaxies. Yes, a single explosion can produce more light and energy than the billions of stars in a galaxy combined. Imagine being able to see a starburst that is brighter than an entire galaxy of stars. For weeks or even months, these explosions can be so bright that they are visible across vast distances in space. The Crab Nebula, for example, was the result of a supernova first observed in 1054. It was so bright that ancient astronomers could see it in the daytime, a cosmic light show like no other. So, why do supernovas shine so brightly? The answer lies in the massive amount of energy they release. When a star explodes, it ejects all of its material into space at incredible speeds. The energy from this explosion is released in the form of light, heat, and radiation. The brightness of a supernova is so intense that it can outshine its entire galaxy for a short period of time. In fact, the explosion is so powerful that it creates elements heavier than iron, like gold and uranium. This is one of the reasons supernovas are essential for life. They're responsible for creating many of the elements found on Earth. But how do supernovas actually form? Stars that are at least 10 times more massive than our Sun undergo this explosive process. These massive stars burn huge amounts of nuclear fuel in their cores, producing energy and heat. As the star continues to burn through its fuel, the core becomes increasingly unstable, and eventually, gravity takes over. The collapse of the core releases enormous amounts of energy, leading to the supernova explosion. Think of a tug-of-war match. On one side, you have the force of gravity pulling the star inward. On the other side, you have the outward push of energy generated by the nuclear fusion reactions in the star's core. As long as the nuclear reactions are ongoing, the star maintains its shape. But once the fuel is depleted, gravity takes over and the star collapses in a violent explosion. This is what makes supernovas so powerful, the explosive release of energy from the collapsing core. Not all stars go supernova, however. Only those that are massive enough, at least 10 times more massive than our Sun, can undergo such a dramatic transformation. Our Sun, for example, is not massive enough to end its life in a supernova. Instead, it will eventually become a red giant, expand outward, and then shed its outer layers, leaving behind a white dwarf. But for the most massive stars in the universe, Their ultimate fate is a fiery, spectacular explosion that marks the end of their lives. Supernovas are not just beautiful explosions, they're also responsible for creating the building blocks of life. When a star goes supernova, it releases a massive amount of energy that creates elements heavier than iron. These elements are scattered across space and eventually form new stars, planets, and even life. In fact, many of the elements in your body, including iron, were created in the hearts of dying stars. Supernovas are the universe's way of recycling material, and they play a crucial role in the creation of everything we know. The study of supernovas helps scientists understand the universe better. By studying the remnants of these explosions, known as supernova remnants, astronomers can learn about the life cycles of stars, the formation of galaxies, and the evolution of the cosmos. Supernovas are also key to understanding the expansion of the universe. When a supernova occurs, it releases a burst of energy that can be used to measure the distance to faraway galaxies. This has helped astronomers determine that the universe is expanding, and that expansion is accelerating due to a mysterious force known as dark energy. But there's still so much to learn about supernovas. While we understand the basics of how they form and what they do, there's still much to discover about the exact processes behind these cosmic explosions. And as we continue to study supernovas, we may find that they hold the key to unlocking even more secrets of the universe. So, why are supernovas so important? They are the ultimate symbol of the power and beauty of the cosmos. They remind us of the incredible forces at work in the universe and the potential for new life and new worlds to emerge from the ashes of dying stars. Every time a supernova occurs, it's a moment of creation, a new chapter in the ongoing story of the universe. And as we continue to explore the mysteries of space, one thing is certain: the supernova will continue to fascinate and inspire us for generations to come. In the end, supernovas are more than just explosions. They are the universe's way of telling us that life, death, and rebirth are all part of the same cosmic cycle. The energy, the light, the elements, everything that makes up the universe, and everything that makes us who we are, is connected to the incredible power of the supernova. So, the next time you look up at the night sky, remember that every twinkle you see could be the remnants of a star that once shone brighter than a galaxy. And perhaps, one day, we'll witness a supernova so bright it lights up the sky for us all to see.